Have you ever gazed at the night sky and wondered, why do all planets rotate in the same direction? Well, to understand this celestial ballet, we must journey back in time to the birth of our solar system. Imagine, if you will, a swirling, chaotic cloud of gas and dust. This is the protoplanetary disk, the cradle of our solar system. As this cloud collapsed under its own gravity, it started to spin, much like a figure skater pulling in her arms during a spin. The direction of this initial spin, that determined the direction in which the planets rotate. And our planets, they've been obediently following this cosmic choreography ever since. Whether it's Mercury's slow pirouette or Jupiter's swift twirl, all are part of this grand cosmic dance. Each planet performing its rotation in harmony with the original spin of that protoplanetary disk. So essentially, the planets are just following the cosmic dance steps laid down billions of years ago. But you might ask, why did the protoplanetary disk start spinning in the first place? Well, the answer lies in the principles of angular momentum and gravity. Let's start with angular momentum. This is a property of rotating objects, and it's a bit like the momentum of an object moving in a straight line, but with a twist, quite literally. Imagine a figure skater spinning on ice. When she pulls her arms in, she spins faster. That's because she's conserving her angular momentum. The same principle applies to the protoplanetary disk. In the early universe, all the gas and dust that would eventually form the planets were moving in random directions. However, even a tiny net spin in one direction, no matter how slight, begins to dominate as particles collide and cancel out their movements in other directions. This initial spin then is amplified over time due to the conservation of angular momentum. As more and more particles start to move in the same direction, the disk begins to spin faster and faster. Now let's bring gravity into the picture. As the particles in the protoplanetary disk move closer together, gravity pulls them in, increasing the speed of the disk's spin. This is similar to our figure skater again. As she pulls in her arms, reducing her radius, she spins faster. In the same way, as gravity pulls the particles of the disk closer together, the disk's speed increases, causing more spin. So you see, the initial movement of the gas and dust particles was like the first tentative steps of a dance. But as the dance progressed, the principles of angular momentum and gravity came into play, amplifying that initial spin and pulling the particles closer together. The result? A spinning, whirling disk of gas and dust, the precursor to the planets in our solar system. In other words, the laws of physics choreographed this celestial ballet, with gravity and angular momentum playing the lead roles. But here's a twist. Not all celestial bodies follow the same dance routine. In our very own cosmic neighborhood, we find Venus and Uranus breaking the symmetry. Venus, for instance, pirouettes on its axis in the opposite direction, a phenomenon we call retrograde rotation. Uranus, on the other hand, has an exceptional tilt, spinning almost on its side in relation to its orbit. How did these planets end up as the cosmic rebels, you may wonder? Well, scientists speculate that these anomalies could be the result of titanic cosmic collisions. Imagine a young Venus or Uranus minding their own business when suddenly a rogue celestial body crashes into them. Such a colossal impact could have altered their original path, causing them to spin in a different direction or tilt at an unusual angle. So, while most planets stick to the original choreography, some have chosen to dance to their own rhythm. If you found this information interesting, don't forget to hit the like button and subscribe to our channel for the latest news updates and engaging stories. Stay connected for more informative content.